Okay, 3.4 video 2. We're going to start out with example 3. And we're just going to solve this equation and approximate the answer to 3 decimal places. Alright, so we've got exponential expressions on both sides of the equal sign. So we're just going to go ahead. Step 1's already done. They're both isolated. So let's go ahead and go to step 2, which was to log both sides. So I'm going to natural log both of these. Oops. Alright. Step 3 says to use that power rule. So we're going to move this down, and remember, because it was in the exponent together, keep it together in parentheses. And the same thing over here. Now, we have options on what we can do right here, but we have x on both sides. So what I'm going to do is I'm going to go ahead and take this natural log and I'm going to distribute it to both of these. So you've got 2x times the natural log of 5 minus 3 times the natural log of 5. And then I'm going to do the same thing on this other side. I'm going to take this natural log of 3 and distribute it to both of these. So x times the natural log of 3 plus 1 times the natural log of 3. Now notice on both sides you have an x. And so we need to get those together. So I'm going to move this one over here to the left. Now also notice that we have 2 that don't have an x in it. And so I want to get them together. So I'm going to move, since I moved my x's to the left, I'm going to move this one on the left over to the right. Alright, so what we have right now is our x natural log of 3 canceled and our 3 natural log of 5 cancels. So now these two here are not like terms, so I cannot combine them, so I'm just going to rewrite it. 2x natural log of 5 minus x natural log of 3 equals, and the same thing over here. These are not like terms, so I'm just going to rewrite it. Now that 1 natural log of 3, 1 times natural log of 3 is just natural log of 3, so I'm just going to write it like that, plus 3 natural log of 5. Now we've got our x's on the left, terms with an x on the left, and terms without an x on the right. So what we can do right here is we can common factor out that x. So we're going to take the x out. So remember, when you common factor, you put it in front. And since we're taking it out, it's going to cancel here. So you get 2 natural log of 5 minus, we're going to take it out right here. So then you just left with the natural log of 3 equals, we didn't touch this other side, so just rewrite it. And so now to solve for x, it's x times the parentheses. So let's just divide by what's in the parentheses. And then, so this is going to cancel. So I'm going to rewrite this up here. So we have x is equal to the natural log of 3 plus 3 natural log of 5 over 2 natural log of 5 minus the natural log of 3. If I copied that correctly. Yes, I did. Alright, and so just be really, really careful putting this in your calculator, but if you put it in correctly, you should get approximately 2.795. Alright, so next moving on to example 4. Alright, so example 4. Again, we're just going to solve the equation. And so we have 3 to the x minus 8 times 3 to the negative x equals 2. Well, this one has something weird in it. It has that 3 to the negative x. And so there's got to be something we can do to get rid of that negative without making it a fraction. So what we can do is, if I can get that to be a 0 as an exponent, then I only have one exponential piece left, because we know any number raised to the 0 power is equal to 1. So how can I make that negative x become a 0? Well, remember, if you multiply it times 3 to the some number right there, when you multiply, you add your exponents. And so negative x plus what would give me a 0? And that's going to be an x. And it's okay to do this. We can multiply the left side by 3 to the x as long as we multiply the right side by it as well. So when we do this, we're going to distribute this 3 to the x. And so the 3 to the x is going to go to the 3 to the x. And the 3 to the x is going to go to the negative 8 times 3 to the negative x. So when I do this, I get 3 to the, remember when you multiply, you add the exponent. So I'm just going to write it out actually. So 3 to the x times 3 to the x minus 8 times 3 to the negative x times that 3 to the x that we just multiplied by equals, and I have 2 times 3 to the x. So all I literally did there is I showed the distributing of that first 3 to the x. So when I put these together, when you multiply, add the exponent, so x plus x is 2x, minus 8 times, same thing, when you multiply, add the exponent, so 3 to the 0, and we're just going to keep this side here. And so we have 3 to the 2x minus 8 times 3 to the 0 is 1 equals the other side. And then we have 3 to the 2x. Well, negative 8 times 1 is just minus 8 equals 2 times 3 to the x. All right, and so now we're ready to start solving. But it looks a little weird here. But we have a 3 to the 2x and we have a 3 to the x. So remember this 3 to the 2x. Alright, so since we have two different forms of x, like we do when we have x squared and x, they're two different forms, we're going to go ahead and get this set equal to 0. So I'm going to subtract this 2 times 3 to the x. It's not a like term with anything, so I'm just going to fit it in here. And so 3 to the 2x, that's bigger. So minus 2 times 3 to the x, and then put the minus 8 equals 0. Alright, so I'm going to come over here to the next column. I'm going to rewrite what I've got written here. So give me just a second, because I don't want to make any mistakes. So I have 3 to the 2x minus 2 times 3 to the x minus 8 equals 0. Alright, well that looks a little confusing, but what we're going to do is, well, first thing too, this is what I started to say a second ago, but this 3 to the 2x, that's the same as saying 3 to the x squared, because remember when you have power to a power, you multiply the powers. And so I can rewrite it like this, 3 to the x minus 8 equals 0. And remember a while back we did some substitution where we let u, or I don't remember what variable it might have been, represent something. So we're going to do that here. So we're going to let, and let's just pick a variable. I'm going to pick z. So I'm going to let z equal 3 to the x, which means where I have a 3 to the x, I'm going to replace it with a z. So when I do that, I have z squared minus 2 times z minus 8 equals 0. Well, now that's just a quadratic equation, so we can solve it. So we're going to factor. And so it's multiplied 8, subtract 2, so it's what, 4 and 2? And it's minus and plus. Set them each equal to 0, so 7 minus 4 equals 0. I'm sorry, z minus 4 equals 0, z plus 2 equals 0, and then solve. So I'm going to add the 4, and I'm going to subtract the 2. But remember, we weren't solving for z, we were trying to solve for x. And z is 3 to the x. So now we're going to replace it back. So, just like we were in like example 2 here, we cannot get like bases. So we can log both sides. And I'm going to have to erase this left side so I have more room. So if you need to, pause the video. So I'm going to come back and erase all of this over here. Because I don't want to squish it up where we can't see it or can't read it. Alright, so first I'm going to work on this first piece, which was 3 to the x equals 4. All right, so we're back to, like I said, I believe it, yeah, example 2 towards the beginning there. So step 1 is to isolate the exponential expression, which it is. Step 2 is to take the log of both sides. So I'm going to natural log both sides. Step 3 is to apply the power rule. And step 4 is to solve for x. So we're going to divide by that natural log of 3. And so x is equal to the natural log of 4 divided by the natural log of 3, which is approximately 1.262. Now, but we still have that other one to work on. But let's think about this. We've done 3 to the x. We did a parent table for it. Even when I had a negative exponent, I ended up with a positive fraction, remember? So there's nothing that you can take 3 and raise it to that's going to equal a negative 2. So therefore, that one doesn't have a solution for it. So the 1.262 will be our only solution. So back on this one real quick. Yeah, whatever you're doing here, this 3 to the extra exponential piece will always have to be greater than 0 because that's that y value. And remember, the range is from 0, not included, up to infinity, so it has to be greater than 0. All right, so that's all of example 4.